In this video, we are going to talk about the AC circuits and how to find the impedance of an AC circuits and drawing phasor diagrams for AC circuits. The purpose of these phasor diagrams and impedance are getting wide knowledge about AC circuits and what is resistive, what is inductive, capacitive, and RL circuit, RC circuit, LC circuit, RLC circuits. So parallel RC circuit, parallel LC circuit, parallel RLC circuits. These are the circuits that we're gonna look at this video. So let's start. So the first one is, I'm starting with the pure resistive circuit. Pure resistive circuit. Pure resistive circuit. So pure resistive circuit. What is pure resistive circuit? Pure resistive means only one resistor in the circuit. There are other voltage supply from here. We don't know that what is that or AC circuit, but the only one resistor for this. For the impedance, so the impedance mean usually we can say the resistance. The resistance is equal to the impedance, not the old times. Impedance of the circuit mean only impedance of the resistor. I know this impedance by Z. So the impedance of the resistor is R. So the impedance of this pure resistive circuit is R. And we're going to draw the phasor diagram. Phasor diagram. So what is the phasor diagram for this is, the phasor diagram, there is a voltage source here. So the voltage source is not leading or lagging. So I am drawn with the horizontal part. This is VR. So I just put V or VR, whatever you like. And the current through this resistor, I code it as I. So the I is like this because the current of a resistor is not leading or lagging the voltage. The current of a resistor or the voltage of a resistor is not leading or lagging the other parts. When we saw the other circuit, you get a clear knowledge about that. This is the first one. So the next one is, the second one is pure inductive circuit. Pure inductive circuit. So what is the pure inductive circuit? Same as that. There is only an inductor here. The voltage across the inductor is V. There is a voltage source. We don't know how it is, but it's a AC circuit. There is only an inductor here. L inductor. Inductance, inductor here. So the impedance is only by the inductor, ZL. So you have to remember the impedance of an inductor is an imaginary part. The impedance of a resistor is the real part, but the impedance of an inductor is imaginary part that we call J omega L. The J stand for the imaginary part. For the omega, we already know 2 pi f into L. This is the impedance of this circuit. So how to draw the phasor diagram for this? There is the common one is the current. So I am starting with the current. So I am starting with the current IL. So IL is there. There is a voltage drop. We need to know that the voltage drop across an inductor is always leading from the current. So there is, we need to draw this as a straight line. This is the voltage. This is the voltage of this inductor. So this is the phase diagram for this. This is the phase diagram for the pure inductive circuit. So the third one, when we go upon you can easily understand the matter. So the third one is pure capacitive circuit. Pure capacitive circuit. Pure capacitive circuit. So how to draw this? Pure capacitive, we already know. Only one capacitor there. I put the capacitance of the capacitor is C, and the voltage across the terminal is V. And I'll take this. So the impedance is equal to only the ZC. So the impedance of the capacitor. So the impedance of this inductor is called J into omega into L. So at the same time, the impedance of the capacitor is also an imaginary part, and it's called minus 1 over J omega C. So minus 1 over J into 2 pi FC. So you have to remember these equations. Impedance of the capacitor is called like this, and the phase diagram for this, the common one is the I. So I'm start with the I, so the IL. So when I already told that the voltage across an inductor is leading, at the same time the voltage across a capacitor is lagging, we see. So the voltage across a capacitor is lagging the current. The voltage across the capacitor is lagging the current. So the fourth one, we already finished the pure circuit. Now we are going to start the RL circuit. RL circuit means there is a resistor and an inductor. There is a resistor, is a voltage source V, and there is a resistor and the inductor. So the current through this circuit, I take this as I. First of all, we need to find the impedance. So the impedance impedance total is equal to ZR plus ZL, because the two resistance are connecting series with this. So the ZR is equal to, we already know the impedance of a resistor is R, plus we already know the impedance of the inductor is J into omega into L. So the total impedance is R plus J omega L. This is the total impedance for the circuit. So we're gonna draw the phasor diagram. This is the important part for this. How we start the phase diagram is, what is the common part of the phase of the circuit. Usually we take in the series, the current is the common part. So I'm starting with the current I. There is a voltage VR and there is a VL here. So how we start VR? VR is not leading or lagging the current. So I am start VR. In here, I take I greater than VR. If VR greater than I, it's go beyond this. So that's not problem. According to your value, you can draw this small or large. So I greater than VR here. I greater than VR here. So let's another thing is the VL. So VL is, I already told you, the VL always leading the current. So VL always leading the current. So this is the VL. So what is the answer for V? There is a vector triangular method. There is V. So the V is equal to VR plus VL. And here you need to note that the angle pi is power factor angle. Power factor angle. That's the phase diagram for this. So the next one, the fifth one was the RC circuit. As same as V, there's a resistor and there is a capacitor here. There's a capacitor here, capacitance of C. I know this, there's a current through this I. So first we need to find the impedance. So the impedance impedance. So the impedance is ZR plus ZC. So ZR, what is ZR? ZR is R. So ZC, we already know that, minus 1 over j omega C. This is the total impedance for the circuit. R minus 1 over j omega C. This is the total impedance for this circuit. How to draw the phasor diagram? I already told that we starting from the common one. The common one is the current I. And the next VR not leading or lagging the current, so VR is placed here. I take that I greater than VR. If your value I less than VR, so VR is beyond, like in here. So VR and VC, I already told you, VC, the voltage drop across the capacitor is always lagging the current. So we see here, so the total V is come from like this. So V is VR plus VC. The angle pi is power factor angle. Power factor angle. Power factor angle. The next one, the sixth one was LC circuit. LC circuit. There is an inductor and the capacitor. Inductor and the capacitor. So there is a voltage, AC voltage V. There is an inductor and a capacitor. Through this capacitor, I take this as I is the current flowing through the circuit. So the impedance is by ZL plus ZC, the impedance of the inductor plus impedance of the capacitor. So impedance of the inductor is called J omega L minus, it's called 1 over J omega C. The total impedance is like this. The impedance, total impedance is like this. So we are going to draw the phasor diagram. What is the common one? The current is the common one. I am starting from this current, and there is a voltage drop across the inductor and the capacitor. The voltage drop across the inductor is always leading the current. So VL is there, and the voltage drop across the capacitor. For I am ending in here, I just come here. So this is VC. Just I took in here VC less than VL. According to your values is sometimes VC greater than VL. So when VC greater than VL, it's come beyond this. It's come beyond this in downwards over the I. It's downward. So the total V is here. This is the V, total V. So the next one is, the seventh one is RLC circuit. The seventh one is RLC circuit. So how we write this RLC circuit? There is a R, there is a L, and there is a C. That's it. So the total impedance come from ZR plus ZL plus ZC. The ZR is R, ZL is J omega L, ZC is minus 1 over J omega C. This is the total impedance, and the phase diagram for this, we just start from the I, because I is the common part I, and VR is here. So I already told that we are not leading or lagging. I am here, I took I is greater than VR. That's why it's smaller than this I line. VR and VL. VL is going always leading. VL is leading there. And the VC always lagging. So in here I took that. In here I took that VC less than VL. So VC less than VL. The V's came from this. This is the V, and it's a pi angle. Pi is a power factor angle. Power factor angle. And the eighth one The eighth one circuit is parallel RL circuit. Parallel RL circuit. RL circuit. So parallel RL circuit. How are we going to draw this? There is an R, there is a L. So there is a R and L. So total I is IR plus IL. So I'm checking that voltage across this terminal is V. So how to find the impedance? How to find the impedance? To finding the impedance, total impedance is equal to Z. Let's have a look at using current. We are using current here. So total current I is equal to IR plus IL. So total current I is voltage drop across the terminal over the total impedance. So IR is again the voltage drop the resistor is V over ZR plus V over ZL. So when we take the V, 1 over Z total impedance is equal to 1 over ZR plus 1 over ZL. So total impedance is equal to ZR into ZL over ZR plus ZL. So this is the total impedance. The ZR is equal to R and ZL is equal to J omega L. So when you plug here, you can easily get the impedance source. And here we are going to draw the phasor diagram. Here is different from this because it's parallel. In here, the common thing is the voltage drop. Current is not a common thing. So I'm starting with the voltage drop. Voltage drop here and the current in here IR and IL. So I already told that current of a resistor or voltage across a resistor is not leading or lagging. So current of a resistor is always be in the same line IR. In here, before that I told you VL and VC. VL leading and VC lagging. But in the same opposite, IL and IC are opposite for the IL lagging and IC leading. Lagging and leading. So the IL in here, IL is lagging, so the IL going to be lagged over here. The total current is given by this line. And here is pi is power factor angle. So the ninth one is the parallel RC circuit. So the same as the one parallel RC circuit is there is a resistor and the and the capacitor over here, same as the parallel RL circuit, IR, IC. So the I is equal to IR plus IC. So the total voltage drop over Z total impedance, total voltage drop over ZR plus total voltage over ZC. So the 1 over Z total is equal to 1 over ZR plus 1 over ZC. So when you solve this, the total impedance is came to us ZR plus dot ZC over ZR plus ZC. We already know that ZR impedance of resistor is R, impedance of the capacitor minus 1 over J omega C. So when you plugged in here, we get the impedance equation. So we are going to draw the phasor diagram for this. What the phasor diagram is look like. In here, the common thing is the voltage. So I am starting with the voltage and the current of a resistor. We know that current of a resistor always be on the same line IR and the current of a capacitor. I already told you the voltage of a capacitor is lagging, the current of a capacitor is always leading. The current of a capacitor is always leading. I see. The total current is given by this line I, and is pi. Pi is power factor angle. Power factor angle. Power factor angle. The last one is the 10th one is the parallel RLC circuit. Parallel RLC circuit. So parallel RLC circuit is look like a resistor, an inductor, and a capacitor. So the same thing as we take the I total here, IR, IL, and IC, capacitance is C, the voltage across this V. So the total current is given by IR, IL, and IC. The total voltage drop and total impedance is equal to voltage drop across the total impedance of a resistor, V over impedance of the inductor, V over impedance of the capacitor. When you solve this, we got to know that ZR dot ZL dot ZC over ZR plus ZC, ZR into ZC plus ZR into ZL plus ZL into ZC. This is the total impedance. We know that ZR, impedance of the resistor is R, impedance of the inductor is J omega L, impedance of the capacitor minus 1 over J omega C. So how to draw the phase diagram is, let's start from the voltage, because voltage is the common thing. The voltage drop across this, and the IR is always in here. So I draw the IR is here, and IL is always lagging, IL, and IC is always leading. I am taking IC greater than IL. So the final current is given by this line I total I. The pi is the power factor angle. Power factor angle. So I think this video has given you a more explanation about the subject. Thank you.